Hi, welcome to my video on proving a quadrilateral is a parallelogram. And I'm going to do several examples to show you how that's done. Proving a quadrilateral is a parallelogram. Ways to prove a quadrilateral is a parallelogram is prove that opposite sides are parallel. Another way, prove that opposite sides are equal. Another way is that's two pairs of opposite sides parallel, two pairs of opposite sides equal. Another way is to prove one pair parallel and equal. And another way to do it is to prove two pairs of opposite angles equal. And another way to do it is to prove that the diagonals bisect each other. So that's 5 ways we can prove that a quadrilateral is a parallelogram. So let's do some examples of some proofs. And if you want to pause the video and work these out beforehand, be my guest. So here we go. Given this diagram, and it says that triangle ABC is congruent to triangle ABC is congruent to CDA. Prove that ABCD is a parallelogram. So we are given, so there's only one given there. So triangle ABC is congruent to triangle CDA. That's a given. And if these triangles are congruent, then I can say that this angle here is equal to this one, and this angle here is equal to this one, and get the parallel lines, or it's options. I can say that this side equals this side, and this side equals this side. That's probably the better way. Let's go with that AB is equal to DC, and say that AD, so AB is equal to DC, keep track, and then AD is equal to CB, and that's CPCTC, corresponding parts of congruent triangles are congruent. And notice now that we have ABCD is a parallelogram, and the reason is we have if a quadrilateral has two pairs of opposite sides equal, then the quadrilateral is parallelogram. That's the easiest way. We could have also said that this angle here is equal to this one, making these parallel, AB parallel to DC, converse to PLT. And then we could have said that that angle there equals that one. This angle A here, right here, this angle here, and then these two would have been parallel to each other by converse of the PLT, and I would have had a parallelogram because opposite sides are parallel. So different ways to do the proofs. Okay, let's look at this one. PQTV. PQTV is a parallelogram given. QRST. QRST is a parallelogram given. Prove that PRSV, the big one, is a parallelogram. So I have all sorts of parallelograms, but how am I going to use the properties of these to prove that this is a parallelogram? Well, we have the opposite sides equal here, and the opposite sides are equal here. That means that PV is going to equal RS by transitive. And let's see, let's go that way. Let's go with PQTV is a parallelogram given. And that means that PV equals QT. And that's opposite sides of parallelogram are equal. And now let's go with PV is parallel to QT. Definition of a parallelogram. So notice, because this is a parallelogram, PV is equal to QT, and PV is parallel to QT. Okay, let's name the other parallelogram. QRST. QRST is a parallelogram. That's a given. So now I'm going to do the same. So that means that PT is equal to RS, because opposite sides of a parallelogram are equal. And notice I didn't put them together because I wanted to use this parallelogram giving you these statements. Then I wanted to use this parallelogram using these statements. Yet they're the same reasons, but I just didn't want to put them all together. And that's they're parallel, because as a parallelogram, then this is a parallelogram. So this QT is parallel to RS, and QT is equal. So if this is a parallelogram, parallel lines is because definition of parallelogram. Now, what we have is that if PV is equal to QT and QT equals RS, that means that PV is equal to RS by transitive property of equality. Again, and that's in numbers 2 and number 5. I put the numbers there so you can 2 and 5 go together, and we get PV equals RS. And now, parallelism is not a transitive property. Notice that we got PV parallel to QT, we got QT parallel to RS. So what happens is that PV is parallel to RS, but it's not transitive property. We have to make a statement. If two segments are parallel to the same segment, then they are parallel to each other. And as a result, we got PV equals RS. PV is parallel to RS, so that means that PRSV is a parallelogram, because we have one pair. That's not an S. One pair of opposite sides are equal and parallel. Equal and parallel. Because we have one pair equal and the same pair parallel, then this is why this is a parallelogram. Okay, let's continue. We have a diagram. It says that this diagram we have PT parallel to VAV, BC and CB and TV bisect each other. That's the givens. We have to prove that PVAT is a parallelogram. So we have PT is parallel to AV. So I have one pair of sides parallel. I can either get the same pair of sides equal, or the same pair, or another same pair equal to get one pair equal and parallel, or I can get the other pair parallel, these PV parallel to TA, and I'll have two pairs of parallel sides, and we have parallelogram. So here we go. Number one. Let's see. I got a bisect here. Let's look at the bisect. Bisect, if they bisect each other, CB and TV bisect each other, that means that OC is equal to OB and OV is equal to OT. They bisect each other, they're equal. So I can get angle 1 equals angle 2 VOAT. So I can get these triangles congruent by side, angle, side. And that means I can pick up this angle here equals this one, angle 3 equals angle 4, CPCTC. And then I can pick up that this side is parallel to this one, and I'll have a parallelogram. So here we go. PT is parallel to AV, better be careful, don't want to get sloppy, AV, given. Number 2, B, C, and TV bisect. I'm going to say each other. I just left that out there. Bisect each other, given. Could have put it all in one statement. And now, because they bisect each other, that means that OC equals OB right here, and OV equals OT. That's definition of segment bisector. And now we have angle 1 equals angle 2 VOAT. These two lines, or these two segments, are cutting each other, therefore the vertically opposite angles are equal. That means I have the triangles congruent. And what triangles? COV is congruent to BOT, and that's side, angle, side. Side, angle, side, congruency. And because I have the triangles congruent, now I can have angle 3 is equal to angle 4. Triangles are congruent. 3 is equal to 4. And that's CPCTC. Corresponding parts of congruent triangles are congruent. Because these two angles are equal, that means that PV is parallel to AT. That's the converse of the PLT, alternate interior angles equal. That means if the alternate interior angles are equal, then the lines are parallel. And now we have this side, PV is parallel to TA. So now we have a PVAT is a parallelogram by definition of a parallelogram. Or we could say it's a parallelogram because there are two pairs of opposite sides parallel, which is the definition of a parallelogram. So that's using the properties, the statements, opposite sides, parallel, two pairs of opposite sides equal, one pair equal and parallel, or parallel and equal, two pairs of opposite angles equal, where the diagonals bisect each other. If we get any one of these statements, then we have a parallelogram. So that's 3 proofs that I did as examples. So that brings us to the end of this video, but there's 2 more coming, because with quadrilaterals you need lots of practice. And if you like the video, click the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content is on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.